Good day, everyone. Now we are going to tackle about the Orient after the decline of Greek society, Arabian mathematicians, and their works. The first one is Muhammad ibn Musa al-Khwarizmi. He was a Persian mathematician, astronomer, astrologer, geographer, and a scholar in the House of Wisdom in Baghdad. Al-Khwarizmi flourished while working as a member of the House of Wisdom in Baghdad under the leadership of Caliph al-Mamun, the son of the Caliph Harun al-Rashid, who was made famous in the Arabian Nights. The House of Wisdom was a scientific research and a teaching center. One of his works is Hisab al-Jabir wa al-Muqabala, or the science of reunion and reduction. The words refer to the two principal operations the Arab used in solving equations. Reunion refers to the transference of negative terms from one side of the equation to the other, and reduction to the combination of like terms on the same side into a single term, or the cancellation of like terms on opposite sides of the equation. For example, in modern notation, the equation 6x squared minus 4x plus 1 is equal to 5x squared plus 3. Reunion gives 6x squared plus 1 is equal to 5x squared plus 4x plus 3. We will transfer the negative term, which is negative 4x, to the other side of the equation. And in reduction, we will subtract 6x squared to 5x squared since they are like terms but on opposite sides of the equation, and same as 3 to 1. Now, this will give us a new equation, x squared is equal to 4x plus 2. While in dealing with quadratic equations, Al-Khwarizmi divided them into three fundamental types. First, x squared plus ax is equal to b. Second, x squared plus b is equal to ax. And the third, x squared is equal to ax plus b. Abu Kamil Suja ibn Aslam ibn Muhammad ibn Suja. He was an Islamic mathematician and one of Al-Khwarizmi's successors, and applied algebraic methods to geometric problems. Abu Kamil Suja is sometimes known as Al-Hasib al-Misri, meaning the calculator from Egypt. Abu Kamil made important contributions to algebra and geometry. He was the first Islamic mathematician to work easily with algebraic equations with powers higher than x squared. The Muslim encyclopedist Ibn Khaldun classified Abu Kamil as the second greatest algebraist chronologically after Al-Khwarizmi. The Fihriст, or Index, was a work compiled by the bookseller Ibn an-Nadim around 988. It gives a full account of the Arabic literature which was available in the 10th century, and it describes briefly some of the authors of this literature. The Fihriст includes a reference to Abu Kamil, and among his works listed are 1. Book of Fortune, Book of the Key to Fortune, Book on Algebra, Book on Surveying and Geometry, Book of the Adequate, Book on Omens, Book of the Kernel, Book of the Two Errors, and Book on Augmentation and Diminution. His Book of Algebra, a title commonly used by early Muslim algebraists, is essentially a commentary on and elaboration of Al-Khwarizmi's work, a much more extensive treatise on algebra than that of Al-Khwarizmi. Abu Kamil's algebra contains a total of 69 problems compared with 40 of his famous predecessor. The book on algebra by Abu Kamil is in three parts. 1. On the solution of quadratic equations. 2. On applications of algebra to the regular pentagon and decagon. And 3. On Diophantine equations and problems of recreational mathematics. The content of the work is the application of algebra to geometrical problems. It is the combination of the geometric methods developed by the Greeks together with the practical methods developed by Al-Khwarizmi mixed with Babylonian methods. The Book of Rare Things in the Art of Calculation is concerned with solutions to indeterminate equations. The book on surveying and geometry was written by Abu Kamil, not for mathematicians, but rather for government land surveyors. Because of the people that it was aimed at, the work contains no proofs. Rather, it presents a number of rules, some of which are far from easy, each given for the numerical solution of a geometric problem. Each rule is illustrated with a worked numerical example. Mainly, the rules are for calculating the area, perimeter, diagonals, etc. of figures such as squares, rectangles, and various different types of triangle. Abu Kamil also gives rules to calculate the volume and surface area of various solids such as rectangular parallelepipeds, right circular prisms, square pyramids, and circular cones. Al-Sabi Thabit ibn Qur'a al-Harani. He was an astronomer and mathematician born in present-day Turkey, best known for translating classic Greek works on astronomy and discovered an equation for determining the amicable numbers. He was a Mandaean physician who was known as Thabit in Latin. Thabit was trilingual, a skill that enabled him to play a key role in the translation movement of 9th century Baghdad. He translated works from both Syriac and Greek into Arabic, creating Arabic versions of important Hellenistic and Greek writings. Thabit's book on determination of amicable numbers concerns the study of numbers. As understood in the Pythagorean sense, it is usually regarded as the first completely original mathematics written in Arabic. The work contains 10 propositions, including one of the construction of amicable number pairs, that is, pairs of numbers each of which is equal to the sum of the proper divisors of the other. Among Thabit's mathematical writings in his book on the measurement of the conic section called parabolic, in it they determined the area of a parabolic segment to be 2/3 the product of its base and height, because this involved inscribing triangles, the length of whose bases were proportional to the sum of the odd integers. Thabit ascertained the formula 1 plus 3 plus 5 plus 7 plus the quantity of 2n minus 1 is equal to n squared. In another of his many works, entitled The Proof of the Well-Known Postulate of Euclid, he sought to prove Euclid's parallel postulate from the 4 remaining ones. Here, he introduced for the first time quadrilaterals in which two based angles are right angles and the angle sides not common to these are of equal length. Khayyam. He was a great mathematician of the 11th century who also contributed in the fields of poetry, astronomy, and philosophy. He was born in Persia on May 18, 1048 in the city of Nishapur, which is now located in Iran. His full name was Giyat al-Din Abul Fath Umar ibn Ibrahim al-Nishapuri al-Khayyami. Omar then moved to Samarkand for higher studies in 1068. There, he got a position in the king's treasury but continued working in mathematics. He made major contributions in the field of algebra and got his treatises published as Risala fil Barahin ala Masail al-Jabr wal Muqabala, or Treatise and Demonstration of Problems of Algebra and Balancing in 1070, which proved to be a milestone in his success as a mathematician. In this, he devised a geometric method for solving cubic equations through intersection of parabola and circle. Omar stepped into geometry and attempted a work through the fifth postulate, the parallel postulate from Euclid's postulates that had been presented in 300 BC. In his publication, Sharma Ashkala min Musadarat Kitab Euclidis, on the difficulties of Euclid's definitions or explanations of the difficulties in the postulates in Euclid's Elements in 1077, he gave an alternate explanation for the parallel postulate rather than proving it, but this attempt opened opened the path of non-Euclidean geometry for the future mathematicians. Khayyam claimed to be the first mathematician to solve every type of cubic equation having a positive root. Since he did not recognize negative numbers as coefficient, it was necessary to consider 14 separate types of cubics that cannot be reduced to linear or quadratic equations on division by x or x squared. Nasir al-Din Tusi. He was known as Muhammad ibn al-Hasan al-Tusi, was an architect, philosopher, physician, scientist, and theologian, as well as a prolific writer. Many consider al-Din Tusi to be the father of trigonometry, and he was perhaps the first person to work on trigonometry independent of astronomy. Al-Tusi composed a variety of treatises on such subjects like logic, philosophy, ethics, arithmetic, and trigonometry. He brought out greatly improved translations of Euclid's Elements, Apollonius Conics, and Ptolemy's Almagest. Al-Tusi did not follow Ptolemy, but questioned epicycle theory as not adequately describing uniform circular motion of a planet about the center of its orbit. He also proposed and studied the Tusi couple, a device in which a circle rolls around the inside of a larger circle with twice the diameter. Giyat al-Din Jamshid Mas'ud al-Kashi. Al-Kashi was born in Kashan, which lies in a desert at the eastern foot of the central Iranian range. At that time, Al-Kashi was growing up. Timur, often known as Tamburlain, was conquering large regions. He had proclaimed himself a sovereign and restorer of the Mughal Empire at Samarkand in 1370 and in 1383. Timur began his conquest in Persia with the capture of Herat. Al-Kashi revised Ptolemy's star catalogue based on fresh observations to give more precise positions for over 1,000 stars. His The Calculator's Key, a work on arithmetic, algebra, and measurement, was dedicated to Ulu Beg. Al-Kashi's treatise on the circumference expounded on the use of decimal fractions. His representation of pi as pi is equal to 3.14, 15, 92, 65, 35, 89, 79, 32, 4, correct to 16 decimals, greatly exceeded all previous calculations and remained so until 16th century when the Dutchman Ludolf van Schuelen reduced pi to 35 decimal places. Al-Kashi was also the author of the Key to Arithmetic, treatise on the chord and sign, as well as several works arising from his astronomical research. Here are the references or sources for the Arabian mathematicians and their works. Again, thank you for watching.